This is our second video on solving equations where the unknown is on both sides. Make sure you're comfortable with the previous video before continuing with this one. Right, let's start with the first question. We've got 2 multiplied by y plus 2, and that equals y minus 1. And we need to solve the equation. That means find the value of the unknown. Now, what I'm going to do is expand the left-hand side. I'm going to multiply that out. Multiplying out, I get 2y plus 4. And that equals y minus 1 on the right-hand side. Next, I'm going to subtract y from each side of the equation. By doing this, I'm going to eliminate the y on the right-hand side, and I will just have negative 1 there. That's going to equal y plus 4 on the left-hand side. Finally, I'm going to subtract 4 from each side of the equation, and that's just going to leave me with y equals negative 5. And that's my solution. Remember, you can always check a solution by substituting it into the original equation and making sure the equation is satisfied. If y equals negative 5, then on the left-hand side we have two lots of negative 5 plus 2. Now negative 5 plus 2 is negative 3, so two lots of that would give you negative 6. And substituting y equals negative 5 into the right-hand side, we'd get negative 5 minus 1. And that also gives us negative 6. And they are equal, so we know that our solution is correct. Let's have a look at the next equation. This is the one we need to solve. We have 2 multiplied by d minus 4, and that equals negative d plus 10. I'm going to start by expanding the left-hand side. That will give me 2d minus 8, and that still equals negative d plus 10 on the right-hand side. Now, what I'm going to do is add d to both sides. By adding d to the right-hand side, I'm going to eliminate the negative d there. So I'm going to have just 10 on the right-hand side and 3d minus 8 on the left-hand side. Now I'm going to add 8 to each side of the equation, and that will leave me with 3d on the left and 18 on the right. Finally, I'm going to divide each side by 3, and that gives me d on the left and 6 on the right, and there is our solution. Now, in both of these, I have tried to be smart about the first step I've taken after expanding the left-hand sides. For example, in this one here, I've chosen to add d to both sides. That eliminated the d on the right-hand side. Now, I didn't have to do that. What I could have done instead is subtract 2d from both sides. This eliminates the d's on the left-hand side, so I get negative 8 there, but it's going to give me negative 3d plus 10 on the right-hand side. Now, I can continue and try to solve this equation, and I will still get the correct answer, but it's just a bit more tricky to deal with that negative 3d. So that's why, rather than subtract 2d, I chose to add d to each side of the equation, because it just made my life a little bit easier. I ended up with a positive 3d on one side of the equation instead of a negative 3d, and that's just a little bit easier to work with. Let's have a look at the next couple of questions. Here's our next example. 6p minus 25 equals 7 minus 2p. As you can see, we've got this unknown p on both sides of the equation. Now, we could subtract 6p from both sides. That would eliminate 6p from the left-hand side. However, we would end up with 7 minus 8p on the right-hand side, and that negative 8p there annoys me a little bit. So what I'm going to do instead is add 2p to each side. By adding 2p to each side, you'll see that we will eliminate the p's on the right-hand side. In fact, what we get is just 7 on the right-hand side. On the left-hand side, we will have 8p minus 25. Now I'm going to add 25 to both sides. That gives me 8p on the left and 32 on the right. Dividing each side by 8, we find p equals 4. And there's the solution. Moving on to the final question, you should be able to have a go at this one for yourself. Just be warned that the solution is not going to be an integer in this case, so take a little bit of care at the end. Hit pause and have a go. Here's what I would do. I would add x to both sides of this equation. That would eliminate the negative x here. Adding x, I get 6x minus 3 on the left-hand side and 4 on the right-hand side. Now I'm going to add 3 to each side. That gives me 6x on the left and 7 on the right. Finally, I'm going to divide each side by 6. And that gives me x on the left and 7/6 on the right. And there's my solution.